Hello, grade 9 students. Let's proceed to our new lesson, which is all about the right and special triangle similarity, or right triangle and special triangle similarity. So the MELC proves the conditions for similarity of triangles, right triangle similarity theorem, and special right triangles theorem. And for the learning objectives, illustrates right and special triangle similarity theorem. Identify the unknown side of the given triangle using the theorems, and proves right and special triangle similarity theorem. So what is a right triangle? A right triangle has two acute angles and one 90-degree angle. So the two legs meet at 90-degree angle, and the hypotenuse is the side opposite the right angle and is the longest side. Okay, so in a right triangle, what are the parts? There are two legs and one hypotenuse. Hypotenuse is the longest side. This is 90 degrees, and the two other angles are acute angles. We have here the right triangle similarity theorem, or RTST. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. Yeah. And repeat, if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So here, we're going to draw an altitude from the right angle here to the opposite side, the hypotenuse. Then the two triangles formed are similar to the original triangle and to each other. So that means consists of three similar triangles already. Proving right triangle similarity, we have here the LL similarity theorem. L stands for legs. So if the legs of a right triangle are proportional to the corresponding legs of another right triangle, the right triangles are similar. That's the LL similarity theorem. I repeat, if the legs of the right triangle are proportional to the corresponding legs of another triangle, the right triangles are similar. Alright, so in every triangle, right triangle, there are two legs always. Sample 1. Angle C and angle F are right angles in the right triangle ABC and DF. So prove that triangle ABC is similar to triangle DEF. So this is now the proof. Two-way proof consists of statements and reason. So for number 1, angle C and angle F are right angles. Also, AC over BC is equal to DF over EF. Reason? Given yan. Number 2, angle C and angle F. Angle C is congruent to angle F. Right angles are congruent. That's the reason. Triangle ABC is similar to triangle DEF. The SAS similarity theorem, meaning side angle side. Yes, since the two sides and one angle are congruent to the two sides and the included angle of another right triangle, then they are similar by the SAS similarity theorem. Sample 2. Given AC is congruent to a side DF and BC congruent to EF, prove that triangle ABC is similar to triangle DEF. Okay, let's have two-way proof here, statements and reason. Number 1, AC is congruent to DF, given. BC is congruent to EF, given also. Angle C is congruent to angle F. All right angles are congruent. Triangle ABC is congruent to triangle DEF by SAS congruence postulate. Yes, because two sides and the included angle are congruent to the corresponding two sides and the included angle of another triangle. SAS congruent postulate. Therefore, triangle ABC is similar to triangle DEF by SAS similarity theorem. It follows. Okay, you can screenshot on this part. Let's proceed to number 3. Given FH is perpendicular to EG. Okay, that's right. They are perpendicular. They form right angles. They form two right angles. FH bisects EG. So that means H is the midpoint of GE. Prove that triangle EFH is congruent to triangle GFH. This is a two-way proof. Statement number 1, FH is perpendicular to EG given angle FHG here is congruent to angle, and angle FHE should say are right angles. That's correct. Because if two sides are perpendicular, then forms two right angles. Perpendicular lines form right angles. Should be right angles. No? Next, triangle EFH and triangle EFH are right angles. Definition of right triangles. FH bisects EG. That's given. Okay. Yeah, yun given siya. Wait, teka, ano to? FH bisects EG. Given. Ito naman, triangle EFH are right triangles dapat, no? EFG naman yung isa. EFH and EFH and GHF dapat yan, no? GFH should be GFH kasi dalawa yung right triangle natin. EFH, triangle EFH and triangle GFH are right triangles. Should be right triangles, not angles. Definition of right triangles. Right. FH bisects EG given. EG is equal to HG, the definition of segment bisector. Therefore, number 6, triangle EFH is congruent to the triangle GFH by LL similarity theorem. Yes, because two legs are congruent. Two legs are congruent. Two legs are congruent. The corresponding legs of two right triangles are congruent. Then the two triangles are congruent by LL similarity theorem. We have here another HL similarity theorem. H stands for hypotenuse and L leg. If the hypotenuse and leg of one right triangle are proportional to the corresponding hypotenuse and leg of another right triangle, then the right triangles are similar. Example 1. Given WJ is congruent to KZ. Angle W and angle K are right angles. Prove that triangle JWZ is congruent to triangle ZKJ. Angle W and angle K are right angles. Statement number 1. Reason given. So angle W and angle K are right angles. Therefore, triangle JWZ and triangle ZKJ are right angles. Definition of right triangles. Yes. So if one of the angles in the right triangle, if one angle in any triangle is right, therefore it's called the right triangle. Next, JZ is equal to JZ, reflexive property of equality. Of course, we're going to what do you call that? Separate the two triangles. Okay, JZ is congruent to JZ, so it's congruent to itself. It's equal to itself. So that's what we call the reflexive property of equality. Next, WJ is congruent to KZ. That's given. Therefore, triangle JWZ is congruent to triangle ZKJ because of HL similarity theorem. Hypotenuse yung JZ plus yung leg. HL similarity theorem. Let's proceed to example 2. Example 2, we have here a triangle RSK. So in the figure given, RB is perpendicular to SK. SR is congruent to KR. Prove that triangle RBS congruent to triangle RVK. So for statement number 1, RB is perpendicular to SK, given. Okay. SR is congruent to KR, given also. Angle RVS here. Angle RVS and angle RVK are right angles. Definition of perpendicularity. Yes, if two line segments are perpendicular, then they form right angles. So if angle RBS and angle RBK are right angles, therefore triangle RBS and triangle RBK are right angles. Definition of right triangles. Also in the figure, RB is equal to RB, reflexive property. Therefore, triangle RBS is congruent to RBK, triangle RBK, by HL similarity theorem. Because the corresponding hypotenuse and leg of the two triangles are what? Congruent. Yes. Example 3. In the figure, AE bisects BD at C. Yes, that's right. Also in the figure, BA is perpendicular to AC, so it forms right angle. DE is perpendicular to EC, so it forms another right angle. Another given, AB is congruent to DE. Prove the triangle BAC or BAC is congruent to triangle DEC or DEC. Statement number 1, AE bisects BD at C, given. AC is congruent to CE, definition of bisector, since point C is since AE bisects BD at C, therefore C is the midpoint. So AC is congruent to CE, definition of bisector. BA is perpendicular to AC, D is perpendicular to EC, given. So if they're perpendicular, therefore angle BAC and triangle DEC are right angles, definition of perpendicular lines. And if they are if angle BAC and angle DEC are right angles, therefore triangle BAC and triangle DEC are right angles, definition of right triangles. Right triangle is a triangle in which one of the angles is right 90 degrees. AB is congruent to DE, number 6 is given here. So therefore triangle BAC is congruent to triangle DEC by HL similarity theorem. That's right. Their leg, the corresponding hypotenuse and leg of the two triangles are, yes, proportional or congruent. So it follows that the two triangles are congruent. No, they are not proportional, they are congruent. Yung sides niya. Si given yun. Next, triangle MER is a right triangle with angle MER as the right angle, correct? MR is the hypotenuse, correct? EY is the altitude. Angle MYE and angle EYR are right angles, that's correct. Triangle MER is similar to triangle EYR, similar to triangle MYE. Therefore, triangle MR is congruent to triangle EYR, is congruent to triangle MYE. Ayun. So, when we try to draw an altitude to the hypotenuse of a right triangle, then it forms three right angles, and these three right triangles are similar to each other. Now we proceed to the special properties of right triangles. When the altitude is drawn to the hypotenuse of a right triangle, number 1, the length of the altitude is the geometric mean between the segments of the hypotenuse, and each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that is adjacent to it. Okay, let's now proceed to geometric mean theorems. In a right triangle, if the altitude drawn from the right angle to the hypotenuse divides the hypotenuse into two segments, then the length of the altitude is the geometric mean of the lengths of the two segments, where x is the altitude while a and b are the segments of the hypotenuse. Let's try to illustrate that. So we have here right triangle MLN. Try to draw an altitude to the hypotenuse, this one. Yes, this segment. This is the what we call the altitude to the hypotenuse, because Ln is the hypotenuse. Then if we try to label the altitude as x, then the divided hypotenuse as a and b, then we can be able to form an equation, or equal proportion, equal ratios, I should say, which is equal to a over x equal to x over b. So this is what we call the geometric mean theorem. Okay, so from if you know the length of a and b, then you can be able to solve for the length of the h, or the altitude to the hypotenuse, by using the formula x equal to square root of ab. This is what we call the geometric mean theorem. Yan, simplify na natin, cross multiply x squared equals ab, no? If you cross multiply this one, if you get the square root of both sides, x equal to square root of ab. Since we are talking about length, dapat positive, no? We disregard the negative one. So x equal to x square root of ab. Yan. So for the altitude, for the length of the altitude to the hypotenuse, it's equal to square root of ab. Yan, geometric mean theorem. And in addition, the length of each leg is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So from here, we can be able to form another proportion. So when you draw an altitude to the hypotenuse, that is d over a is equal to a over d plus c, or c over b is equal to b over c plus d. Ayan. Okay, all you have to do is to memorize these formulas. To solve for the length of the altitude to the hypotenuse, here x go to square root of cd, and then in addition to that, we can form a proportion. D over a is equal to a over c plus d, or d plus d. Tapos c over b is equal to b over c plus d. Yeah, note a and b are the legs of the right triangle. Theorem: in a right triangle, the altitude of the hypotenuse separates the triangle to two triangles, each similar to the given triangle and similar to each other. If triangle ABC is right, with angle B the right angle, BD is the altitude to the hypotenuse AC. Yeah, example here. We have here triangle ABC. It's a right triangle, and we're going to draw an altitude to the hypotenuse from point B to D. That's what we call the altitude to the hypotenuse, right? And the legs are AB and BC. DC is the hypotenuse segment, AC is the hypotenuse, AD is also the hypotenuse segment. Then all these three triangles are similar to each other. So triangle ADB is similar to triangle ABC, triangle BDC is similar to triangle ABC, and triangle ADB is similar to triangle BDC. So the three formed right triangles are similar with each other. In a right triangle, the altitude to the hypotenuse is the geometric mean of the segments into which it divides the hypotenuse. That's what we discussed a while back. Okay. CD in the right triangle, CD is the altitude to the hypotenuse AB. So from here, we can be able to form another set of formulas, because they are interrelated with each other. So CD squared is equal to AD times BD. AC squared is equal to AD times AB. Ayun. BC squared is equal to BD times AB. Okay, all you have to do is to memorize these things. So to solve for CD, you just get the square root of AD times BD. To solve for AC, you just get the square root of AD times AB. To solve for BC, just get the square root of BD over AB. Yeah. Okay, repeat. To solve for CD, get the square root of AD times BD. To get this length of AC, you just get the square root of AD times AB. To get the length of BC, you just get the square root of BD times AB. In a right triangle, each leg is the geometric mean of the hypotenuse and the segment of the hypotenuse adjacent to it. Ayun. So, yan yung simplification niya. CD is equal to square root of AD times BD. AC is equal to the square root of AD times AB. BC is square root of BD times AB. How long is the altitude of a right triangle that separates the hypotenuse into lengths 4 and 20? Yan sinasabi nating geometric mean. How long is A? Square root of 4 times 20 lang yan, which is 80. Square root of 80, 4 square root of 5. Okay? So, simplifying the radical, square root of 80, 16 times 5. So, we have 4 square root of 5. Okay, diba? So, another. Use the figure to the right to solve for x and y. Yun, meron tayong shortcut here to solve for x. To solve for x, we just get the square root of 2 times 10. Over x is equal to x over 10. Dapat 10, no? Meron tayong kakamali dito. Can you still simplify this? Okay, it's written in it's in picture form. To solve for y, tama ba? 2 over x. Two times 10 sana, yung y naman. Eight times 10 naman yung y. 80. So, pwede nating palitan, no? Yeah, pwede natin palitan, insert. Para tama pa rin yung answer natin. So, to solve for x, it's equal to the square root of solve for x is the square root of 2 times 10. Where did you get 10? You just added 2 and 8. So that's equal to square root of 20, diba? Square root of 20, pwede na yung answer na yan. Or, wait. X is equal to 4 times 5, that means 2 square root of 5. In decimal form, square root of 20 is, what is square root of 20 using your calculator? 4.5. 4.5. Yan. Okay, 4.5 yung the value of x. How about the value of y? The value of y is just the product of 8. 8 and 2 plus 8, 10. So 80. 8 times 10 is 80. That's equal to 16 times 5. So 4 times square root of 5. What is square root of 80? 8.9. So therefore, 8.9. Yan. So that's how we solve for x and y. Yun yung shortcut. Ayun. Yan natin ng animation. This is float in. Fly in. Alright, let's continue. So, yeah. For x, 2 times square root of 2 times 10 lang yan. So, square root of 20 or 4.5. For y, 8 times square root, 8 times 10, which is square root of 80 or 8.9. Now, let's proceed to the special right triangles. There are two special right triangles. These are the isosceles right triangle or the 45 degree 45 90 theorem. Yeah, so why they are called special? Because we can be able to solve the lengths of its sides without using the Pythagorean theorem. So parang may shortcut dito. So in a 45 90 triangle, the length of the hypotenuse is equal to the length of the leg times square root of 2. So that means since this is an isosceles right triangle, the legs are equal, right? And to solve for h, no need to use Pythagorean theorem. Just multiply s by square root of 2. So for example, if s is 4, therefore the other leg is also 4, and the hypotenuse is 4 times square root of 2. So yun, that's the formula. S is square root of 2, the hypotenuse. Now, about in the 30, 60, 90 theorem, it is another kind of special right triangle, the 30, 60, 90 triangle. Okay, why it's called special right triangle? Because we can be able to solve the legs or the hypotenuse, okay, without using the Pythagorean theorem. So parang may shortcut in solving the legs and the hypotenuse. So ano yung theorem na to? In a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg, and the length of the longer leg is square root of 3 times the length of the shorter leg. Yan. So we have here 90 degrees, 30 degrees, 60 degrees. It states that the length of the shorter leg is 1/2 the length of the hypotenuse. I mean the opposite. Yes, the opposite. The shorter leg meaning the opposite of 30-degree angle. The opposite of the 30-degree angle is 1/2 the length of the hypotenuse. For example, the hypotenuse is 10, therefore the shorter leg is 5, 1/2 of 10. And how about the length of the longer leg? Just multiply the shorter leg by square root of 3. So if this is 5, shorter leg is 5, the longer leg is 5 square root of 3. That's how we solve 30, 60, 90 triangle. Yan. So PT is twice PR, RT is PR times square root of 3. Note, longer leg is the leg opposite 60 degree, shorter leg is the leg opposite 30 degree, and hypotenuse is side opposite the 90 degrees. Samples. Find the length of the hypotenuse of an isosceles right triangle. So if the leg is 7 square root of 2 centimeters, how long is the hypotenuse? Yes, what's the rule? In dealing with the isosceles right triangle, just multiply the leg. So for the hypotenuse, C, just multiply the leg by square root of 2. So 7 square root of 2 times square root of 2 again. Multiplying the radical, square root of 2 times square root of 2, square root of 4. Square root of 4 is 2, so 7 times 2 is 14. Therefore, the hypotenuse is 14. Next, another. Find the length of each leg of a 45 90 degree triangle with the hypotenuse 12. Now, this time, given yung hypotenuse. If the hypotenuse is 12 centimeter, what is the length of the legs? Equal yung legs niya. So, what will be our formula? Just divide 12 by square root of 2. Okay, so the leg is hypotenuse divided by square root of 2. So 12 divided by square root of 2 can be solved by rationalization. 12 over square root of 2 times square root of 2 over square root of 2 is 12 square root of 2 over square root of 4. But square root of 4 is 2, so you can still simplify. 12 divided by 2 is 6. Therefore, the length of the legs of the isosceles right triangle is 6 square root of 2 centimeters. Next, number 3, find the length of the longer leg and the hypotenuse. Yes. So, this is 90, that's 30. It follows that this angle is 60 degrees. And this is the longer leg, this is the shorter leg. Okay. So that if this is 30 degrees and this is 30 meters, opposite of the 30 degree angle, shorter leg. Therefore, the hypotenuse is twice 30, which is 60 meters. And what is the length of the longer leg, opposite of 60 degrees? Just multiply 30 by square root of 3. So 30 times square root of 3 meters is the length of the longer leg. Okay, let's have exercises. Given figure on RIST, identify the right triangle RIS. Identify the three pairs of similar triangle. Okay, that's easy. Number 1, triangle SIT is similar to triangle RIS. That's correct. Triangle RIT is similar to triangle RIS. And triangle SIT is similar to triangle RIT. So that means if we draw an altitude to the hypotenuse, then it forms three similar triangles. They are similar with each other. Direction: given the triangle SIT, identify the hypotenuse, altitude, segments of the hypotenuse and the legs. So triangle SIT, what is the hypotenuse? SI, that's correct. Altitude, IT. And legs, what are the legs? ST. Dalawa dapat. IT is the altitude, the legs are ST and IT, diba? Yes. What is this? Ano to? Triangle RIT. Triangle SIT ang sinasabi dito. So, the legs are ST and IT. Dapat ST and IT. Include natin yung IT. Yan, IT. IT is the same as the altitude is also the length. Next, identify the missing length as indicated by using geometric mean. Leave your answer in simplest radical form. Number 1, what is x? Ano lang yan? 16 square root of 16 times 9. No, 12. Diba 12? Kasi 16 times square root of 16 times 9 is solve for x. Solve for x naman dito, 9 square root of 9 times 25 lang yan. So 3 times 5, 15. Number 3, solve for x in number 3 given the altitude 12. Ayan, what will be your x over 12 equals 12 over 16. So 144 over 16. Ayan. 9. Diba? In number 4, ganun din. Same procedure as in number 3. X over 48 equals 48 over 64. 48 times 48 divided by 64. 36. And number 5. Same procedure as in number 3 and 4 also. 6 square root of 13 times 6 square root of 13 by 13. Answer is also 36. Next, complete the proof. To prove the right triangle similarity, choose your answer from the box below. So we have here two similar triangles, CAN and FUG, triangle FUG. Number 1, of course, given. Number 2, triangle. Here, number 2. OF is congruent to blank. Number 2 is NC. NC is congruent to OF, correct? And given yung reason. Number 4, triangle can is congruent to triangle fag. And number 5, by SAS, similarity theorem. Yeah. And also given the feature at the right, answer the following. The hypotenuse of right triangle ABC is AB, correct. The shorter leg of right triangle ABC is BD. The shorter leg of right triangle, mali na yata yung numbering ko, is followed here. Just never mind the numbers. The shorter leg of right triangle ADC is CD, of course. Basta opposite ng 30 yung shorter leg, 60 degrees opposite ng 60 degrees longer leg. Number 4, altitude of the hypotenuse of triangle ACD. CD. Yeah, CD. Number 6 is AC. Now, number 7, when CD is 2, then blank is equal to 4. CD is 2. CB, di ba? Hindi, what we're trying to say. CD. Hindi, sa kabila pala. So, AD is equal to 4. Wait. Nagagula na ako dito. Number 7. Hindi. Nung numbering nga pala. So, for the last 3 numbers, here. Kasi na-double yung 1 dun eh. So, for number 7, number 8, AC is equal to 4. And when CB6 blank is 6 square root of 3. Answer is AC. And when CB6 blank is equal to 3 dB, right? Hindi na nakikita yung answer dito. Ipat natin. Yan. So, ito yung answer for the problems. For the exercises 1 to 10. Kaya lang, wrong numbering dito. Just adjust na lang tayo dito, right? Another, identify the value of x in each of the following. Number 1, very easy. 6 times 2, 12. Number 2, 10 times square root of 3, 10 square root of 3. In number 3, 16 divided by 2 lang yan, which is 8. In number 4, 18 times square root of 3. And number 5, 1 up of 26, 13. Okay. Yan. From current slide, diba? Alam niyo yun? Special right triangle theorems to. Another, identify the value of x in each of the following. Very easy. This is, if this is 24, this is 12. So x is 12 square root of 3. Tingnan ba? Parang mali na yung answer dito. Wait. Parang mali yung answer. I'm sorry for that. Mali yung answer eh. So, insert na lang tayo. Ito. So, for number 1, what's the answer? 12 square root of 3. Diba? 1 half of... See, 1 half of 24 is 12. So, 12 square root of 3 yan. Square root of 3, yun. Next, number 2, isosceles right triangle. If this is 12, that is 12 square root of 2. Okay, very easy. Medyo kamali tayo ng answer kanina. How about in number 3? If this is 30, what is x? Okay, same procedure as in number 1. So 1/2 of 30 is 15. 15 square root of 3, the opposite of the opposite of 60 degrees. And in number 4, here. Okay, that's easy. And an isosceles right triangle. If the legs is 12, if the length of the legs is 12, so just multiply the leg. The hypotenuse is equal to the hypotenuse. I mean, the length of the hypotenuse is the leg times square root of 2. And for number 5, just divide 10 by square root of 2. Even the hypotenuse. 10 divided by square root of 2 is 10 square root of 2 over 2. So 5 square root of 2. 5 square root of 2. Yan. Yan natin ng animation. Floating. Fine. Yan. Then lakayin natin ng konti. Okay. Let's continue. I think it's the last exercise. Okay. Meron pa. Meron pa pala. So I think this is the last exercise. Determine the missing sides of the right triangle given the triangle's answer only. For number 1, what's the length of BS? Square root of 16. 8 times 2 is 4. How about RS? Square root of 2 times 10. 2 square root of 5. ST? Square root of 8 times 10, square root of 80. So 4 square root of 5, that's correct. Next, for letter B, find the missing parts. OR is 6, RM is 9, what is PR? Okay, X is to 6, 36 divided by 9, 4. Next, number 2, for letter B, PO is 9, PR is 3, PM, what is PM? Oh, medyo ano, square root of ano yan, 9 is equal to square root of 3 times 3 plus x, so 9 plus 3x. 9 plus 3x equals 81. 81 minus 9 is 72 divided by 3, 27. Next, PR is 4, PO is 6, PO is 6. What is RM? Same procedure as in number 2. Okay, PO is 6. 6 is equal to 4 times 4 plus x. 36 is equal to 16 plus 4x. 36 minus 16. 20. Divided by 4. 9, tama ba? 36 diba, is equal to 4 times 16 plus 4x. 20 divided by 4. So the answer is 9. Tama ba? PR is 4, tapos PO is 6. What is RM? So ganun, 6 is equal to square root of 4 times 4. 16 plus 4x is equal to 36. 36 minus 16. 20 divided by 4. 4x. So dapat ano, teka, nalito na ako. 36 equal to 16 plus 20 divided by 4. 5. 5 plus 4, 9, tama. Okay. course. Thank you very much for listening. Medyo mahaba tong ating discussion natin sa right triangle similarity. So, I'll see you again next time. Goodbye.